as promised, we're now going to create a BigFraction class. Now, one thing we know about fractions is fractions have numerators and denominators. We also know this: if you start adding a bunch of fractions together, one thing that tends to happen is the numerators and denominators will tend to get very, very, very large. If you take the first few reciprocals, you start adding them together, you'll notice that this pattern occurs. Therefore, what you don't want to do is use even longs as your numerator and denominator. One thing we should be able to do is compute the 5,000th harmonic number. What is that? That is the number that comes from adding the first 5,000 reciprocals. And you know that that's going to have a huge numerator and a huge denominator, and that type overflow would cause errors and exceptions and unending misery. So we will therefore use big integers rather than integers as state for our fraction. So to get started, let's go ahead and do the obligatory import. Big integer, and this class is named BigFraction. Now inside this class we will create two pieces of state. Private big integer num. And then we're going to create one called the nom. Now, one thing you'll discern if you go reading in the API guide for the big integer is big integers are immutable. And we're going to preserve that immutability. Our big fractions are going to be immutable. And we can make them that way by making the numerator and denominator final. Now, both requirements are here for constantness. One, the variable is final. Two, the object being pointed at by the variable is immutable. Therefore, these things are actually const, which is a very good thing indeed. Now we're going to say public. We need a general purpose constructor. Okay, big integer, and so we're going to put in a big integer num big integer denom. Okay, and now we can go like this, and let's go ahead and just start off this way. Okay, this dot num is num, this dot denom is denom. Now, one thing we don't want to do is operate in the dark, so we're going to go ahead and make a toString method while we're here. And the toString method will be the obvious choice. Return string.format of %s by %s, comma, num denom. Okay, so there's our, and now finally, let's close the class and let's give it a main. Okay, so let's go ahead and give it a main. And inside this main, let's start off by going BigFraction. F is equal to new BigFraction. And we can already see some clumsiness emerging here. A big integer. And then we'll get 2/3. Three. All right, let's just see what it looks like. Okay, so we'll see what our big fraction looks like. So far, we're not making many demands, and we're keeping it very, very, very simple. Okay, so we just have our toString method. So let's go ahead and WQ on that. We're going to javac it. See how many compiler errors we racked up. Oh, I forgot a semicolon. It's almost inevitable you're going to get a compiler error. Okay, let's do that again. Return type required. Whoops. Oh, and here's another kind of silly mistake. I have big integer on the brain. The name of the constructor, of course, is the same as the name of the class, BigFraction. Oh, whoops. I don't want Python. I want Java. Ooh, how pretty. Now I'm going to give you something to complain about. And maybe you can foresee this, but let's go ahead and do this. We're going to make some more BigFractions here. All right. Let's see. I'm going to yank that. 2p. All right. So I'll call this BigFraction G here. And let's change 2 and 3 to 2 and 4. And let's make this print out G. All right. And then this is going to be H. These are throwaway names, so I don't really care about the value as documentation. And then I'm going to put in a -4 here. All right. So there you go. All right. And then we're going to print out H. So we're making 2/3, 2/4, and 2 by -4. All right, let's see what it looks like. I run my code. Frightening, it compiled. Are we happy? I'm not happy. Look at that. First of all, that negative on the bottom is ugly. Let's start with that. Having a negative on the bottom, you know, that's the same thing as -2/4, and it looks a whole lot better when the negative is out in front in the toString method. So for that reason alone, let's go ahead and fix that particular objection. Now, one thing I'm going to do is, this is a nice trick, is use num and denom as local variables and not assign the this dot till the end, because the this dot is a final variable. You can only assign once. So let's go ahead and say something like this. If denom dot compare to a big integer, if this is less than 0, let's just flip the signs at the top and the bottom. And we saw when we looked at big integer, we can go like this. Num equals num. So I'm going to negate that. And negate the denominator. Okay, so far that's it. That looks much better. Okay, that looks a whole lot better. Let's just content ourselves with that. Let's compile again. This is Chicago. We compile early and often. Actually, it's Durham. All right, and let's run it. That looks better. -2 is there. Now, we still have another problem. The fractions are not fully reduced. Now, Mrs. Wormwood taught us how to reduce a fraction by keeping on dividing common factors in until there are no more. But that's kind of inefficient. The smart thing to do is to find the greatest common divisor of the numerator and denominator and divide it away. Because when you do that, the greatest common divisor of the things that are left of the quotients will be 1. And that means the fraction is fully reduced. Now, in the interest of use wheels, don't reinvent them, we can go into the documentation here, and we can see in big integers documentation, there's a GCD function, greatest common divisor. It uses the Euclidean algorithm to compute the greatest common divisor, which is nice and efficient because it's big O of log of n. All right, and we're going to use that rather than making one ourselves. let's just be smart and do this. We're going to come in here and we're going to do this. We're going to say big D is equal to num.gcd of denom. Okay. Then what we can do is we're going to come down here because everything's cleaned up. All right, we're ready to assign, I think. Okay, you can go ahead and divide out by that quantity. And hopefully these fractions will be fully reduced. Let's see if that happens when we run our code. Okay, compile. Run. EPONG, yes! Our fractions are fully reduced. Here, let's stick something in here that's just obnoxious, just for fun. Let's go down to the end here, and we'll put in like a couple of big numbers, just to get under its skin. Here, I'm going to put in this number. Wait a minute. I want to say that's like 6 to the 5th power. And then down here, I'm going to put in this famous number that every nerd needs to know. That's 2 to the 20th power. And let's see if it looks, if it still looks good. We'll subject it, you know, we have our shiny new toy. Let's break it. If we can. Oh, look at that. That 243, that's 3 to the 5th power. And then the thing on the bottom, I recognize that immediately, don't you? That's 2 to the 15th power. We're looking pretty good here. We're smelling like roses. So far, what have we got? We have a BigFraction class that is smart enough to keep our BigFractions fully reduced. And I think this is a good time for us to end this part. We have now laid down the preparations, and we're going to begin to go in and make this class more attractive. Okay, so for now, that is all. See you next time.